Hello, welcome to your first official Chem 2 lesson. That's right, people. We are moving on. We're still in Chapter 9. This is technically Chapter 9.2. You'll see why it's so important that you understand Chapter 7.2, writing equations, Chapter 8, balancing equations, Chapter 9, stoichiometry, specifically mass to mass, once we get through this lesson. So, Chapter 9 is limiting and excess reactants, and it's using stoichiometry in chapter 7 and 8. So that's why it's important. Just to let you know, let me get my pen here. You can write limiting reactant as LR and excess reactant as ER. That's what I do. Some people write it XR, excess, whatever. Doesn't matter. But if you see those abbreviations, just know that that's the topic we're on. All right, let's begin. So, no, I don't know why that's there. Ignore that for now. Okay, so a couple of vocab words and then the rest are just problems. So limiting reactant, like I said, LR, it's the chemical, it can be a compound, it can be an element that is used completely in a chemical reaction. So there's just enough or not enough at all. Okay, so think about you need $10 to get a movie ticket and you only have $9.50. Okay, you are limited. You cannot move on to that movie. That's kind of what the limiting reactant is. And then on the other side, my keyboard's not working. Hello, there we go. You have the excess reactant, which like I said, I abbreviated ER, but I've seen people abbreviate it XR. It doesn't really matter to me. It's whatever you're going to remember. Okay, so the excess reactant is exactly what it sounds like. It is left over. It does not get completely used, so there's extra. There's an excess of it. And remember, reactants are the starting materials. They're to the left of the arrow. So if you have multiple reactants, you have to figure out at least what the limiting is. And you'll see why in a minute. Okay. So now to the random bullet point that showed up even though I didn't want it to. So we're on the third bullet point now. You have to consider the reactant side of the equation. So like I said, to the left of the arrow. If there is only one reactant, it is automatically the limiting reactant and there is no excess reactant. There are going to be situations where you only have one reactant and it decomposes. Okay, if that happens, I'm not tricking you. You don't have to actually solve. You don't have to figure out which is the limiting and which is the excess because there's only one. It's automatically the limiting and there is no excess. But if you have multiple reactants, you do have to figure this out. So we're going to use stoichiometric calculations to determine the limiting and excess reactant. Specifically, we're going to be using mass to mass. You're probably groaning. It is a lot of writing, but it's not hard, guys, okay? It's always constantly the same setup over and over again. The numbers are just changing. So you'll see what I mean in a minute by this, but the number that you're solving for by stoichiometry is what you need. The number you're given is what you have. Okay, so once again, what you solve for is what you need. What you're given is what you have. Okay, it'll make way more sense in a minute, but that will be a lifesaver for you. Okay, so eventually this is going to get more complicated. I'll have you write it first. I'll have you balance it, and then you start. So that's why I'm saying chapter 7 and 8 are so important. But right now, to take it a little bit easier on you, I'm going to give you simple equations. So pause the video, copy this down, make sure you copy it correctly, and then balance it and just stop. Okay, so as far as balancing goes, this is a pretty simple one. Hopefully you got 2 on 2. Okay, if you don't write this correctly and therefore you don't balance it correctly, or you just don't balance it correctly if it's already written, it's going to mess everything else up. Okay, so I'm going to tell you right now, there's 2 ways to figure out the limiting and the excess reactants. You only have to do one. I'm going to do both ways. You do not have to do it both ways. I'm going to do it both ways to show you it doesn't matter which way you do it. So here is one reactant. Here is another reactant. Okay, I have to figure out which of those is my limiting, which is my excess. So I'm going to start with the H2. You could have started with O2. It doesn't matter. I'm going to do it both ways. I would say for at least this first equation, watch both ways so you know what I mean. After that, you can do it whichever way you prefer. Okay, so I'm given 3 grams of H2. So we're just doing stoichiometry. Okay, I don't care about this right now. I don't care about it. I only care about the reactants. So if this is my known, this has become my unknown for now, technically. Okay, so I have mass to mass. I've got 1 mole of my known, it's constant, over the molar mass of my known, which is 2 grams because H plus H. I'm not using the coefficient. I'm only using the typed information. Okay, mass to mass. Now I do my mole ratio, my unknown coefficient, which is the other reactant I'm concerned about, over my known coefficient. That's the only time you use the coefficients, guys. The only time you use the coefficients is in the mole ratio. That's it. Then you can ignore them. All right, and then my unknown molar mass, O2. The oxygen is 16, so 16 plus 16. And then 1 mole of unknown on the bottom. Okay, notice I have a unit, moles, or grams, and I have a label from the element or if there's compound. If you don't do that on every number, you're going to miss half a point every time. All right, run that through your calculator. Remember, your number should be close to mine. I have rounded maybe a little bit different than you. That's fine. All right, so I get 24 grams of O2. Okay, once again, what you solve for is what you need. I need 24 grams. I have, look back at the problem, I have 7 grams because that's given to you. Okay, I need $24. I only have 7. Think of it like money. All right, I'm not going to go on. I want to do it the other way just so you see it doesn't matter. Okay, so now I'm going to start with O2. I have 7 grams of O2. And some people like to do it both ways just to check themselves when they get started with this. The good news is it's actually not that much work because all your numbers are up here. So now I'm going to switch it. 1 mole of O2. The molar mass of my known. What's right here? 32, I already solved. So I don't have to do the math again. I can just look back. Once again, you don't have to do both ways. But if you want to, you don't have to. It's just a good check. All right, 2 moles of my unknown now, which is H2. Over, I'm just basically flip-flopping everything. All right, so if I do it this way, plug that into my calculator, I get about, like I said, your number may be a little bit different, 0.88 grams of H2. I need that. Okay, I look back at the problem. I have 3 grams. Okay, so this is what I'm saying. It doesn't matter which one you do, which method you do. So go back to the first part. I need 24 grams of oxygen. I have 7. I need $24. I have 7. Can I buy my item? No. So according to that, my limiting reactant is O2. Okay, by default, H2 should be my excess, right? Because there's only 2 I'm comparing. Okay, let's try it the other way. I did it the other way. I need 0.88 grams of hydrogen. I have 3. I need 88 cents. I have $3. I'm going to have extra money left over. In this case, I know that H2 is my excess. By default, O2 is my limiting. Okay, so that's what I'm saying. It doesn't matter if you do it this way or if you do it this way. It doesn't matter. You should get the same answer. You do not have to do it both ways unless you want to check yourself. If, for example, down here, I got that H2 was my limiting, and up here I got that O2 was my limiting, something went wrong in here, okay? You should get the same results no matter which way you do it. Okay, so now I determined that O2 is my limiting and H2 is my excess. Okay, and we're going to stop there for now, and I'll tell you more later, but I just want you to focus on this process right now. All right, let's try another one. Copy that down, balance it. It's another easy one to balance, and try that out. Okay, so hopefully for balancing, you got 1, 4, 1, 2. Once again, this is limiting and excess reactants. That's my point in solving. So I'm only concerned about my reactants, which are right here because they're to the left of the arrow. I'm going to do it both ways. It doesn't matter which you start with. Why don't you start with HF just for the heck of it? Okay? Just go for it. Try that one. Start with HF if you're feeling crazy. I'm going to start with SiO2 and we'll see if we get the same answer. Okay, so I'm given 4.5 grams of SiO2. Do my mass to mass stoichiometry. Hopefully you're good at it by now. If not, you got to practice. Molar mass of SiO2 is about 60. Okay, now my coefficients come into play. Mole ratio, my unknown, because it's the other reactant. I know there's not a question mark under it, but if I'm comparing a reactant to reactant, the one I start with is my known. The other one by default is my unknown. So this is like step 1 of 3. I know, crazy. We'll get there. Okay, so I started with SiO2 and I'm solving for HF. But if you did it the other way, that's fine. I told you to, so hopefully you did. Doesn't matter which way you do it. Just flip-flop all the numbers. Don't forget about units and labels. And like I said, guys, if you're not actually watching these videos or trying these problems, you don't really know how you expect to be successful. All right. So if I do the top method, I solve for 6 grams of HF. That's what I need. If I solve the bottom one, I get 1.5 grams of SiO2. Once again, I need that. Whatever you solve for is what you need. Go back to the problem. Here's what I have. I have 4.5 grams of SiO2, and I have 2 grams of HF. Think of it like money. I need $6. I have 2. Can I buy it? No, I'm limited. So HF is going to be the limiting. By default, SiO2 should be the excess. Check the other way. Down here, I need 1.5 grams of SiO2. I have 4.5. I need $1.50. I have $4.50. I have money left over. So Si, oh, shocking, is the EF, or ER, sorry. By default, HF is the limiting. So like I said, it doesn't matter which method you use or which reactant you start with, you should get the same answer. Okay, you're finding which is the limiting reactant, which is the excess reactant. That's all we're doing right now. I'll tell you why this is important next video. All right, 2 more. Try this one. All right, so you hopefully balanced it. I got 2, 1, 2, 1. Okay, start with whichever one you want. You're only worrying about the reactants, so we're only worrying about this side of the equation right now. Start with whichever you want. Pause the video, do the work, check back with me in a minute. See, I don't always round. Okay, mole ratio, unknown, Over known, you're only looking at the reactants. Your unknown is whatever you didn't start with. Don't forget units and labels. Okay, and just give me a second. Let me do it the other way. And this is real time. I'm not pausing this video as I write. I am just flip-flopping the numbers that I already wrote with the labels and units that are correct. So if you do like to do it both ways, or you want to at least start by doing it both ways till you get the hang of this, don't go back and do the molar masses all over again. They're in the previous method. Whoops, sorry, I was trying to make that darker. Units and labels will kill you if you forget them. Don't do it. I know it's a lot of writing, but it could be much worse. Okay, top method, if I solve that, I get, did I? Oh no, I got that, okay. Top method, I got 19.4 grams of nickel. That's what I need. If I look back in the problem, I have 22.9 grams. Okay, bottom method, I got 132 grams of silver nitrate. Go back to the problem. I have 112. Okay, so I need 132 grams. I have 112 grams. Think of it like money. I need $132. I have 112. I cannot buy that item, therefore I am limited. So my silver nitrate's my limiting. By default, nickel should be my excess. And there's usually a spot on the worksheet for you to actually write. There's like a line that says limiting and then a line that says excess. I just like to write it above as well. All right, looking at the top part here, I need 19.4 grams of nickel. I have 22.9 grams of nickel. I have more than I need, so I'm gonna have extra left over. So by default, once again, nickel is my excess. Okay, it's not bad. You just have to know stoichiometry, balancing, and writing. That's why I said it's a snowball effect. All right, one more for good measure. Try this one, and then that's it. Then you can practice on today's assignment. Once again, if you're not actually practicing the practice assignment and checking your work, I don't have much sympathy for you for whenever you don't do well on the actual graded worksheet. Okay, 3, 4, 1, 4. Pick whichever one you want to start with, but we're only looking at these. If there's more than 2 reactants, only look at the ones I have numbers under. Remember, you do not use the coefficients when you're solving for molar mass. You only use the coefficients in the mole ratio area, which I'm doing right now. Biggest mistake people make is they take 3 irons. Nope, it's just 1. It's just this, not the coefficient. Coefficient only gets used mole ratio. Okay, so there's the first way you could have done it, fine by me. Or maybe you like water, so you want to start there. Doesn't matter. You'll get the same overall answer. You do not have to do it both ways. Also a good way to see who actually watches my videos. Do we have to do it both ways? No, I said it like 400 times. Pick whichever way you want to do it. Unless it tells you on the worksheet, do it both ways. But why would I make you suffer? How could I do that to you? And look, I'm writing this twice. You only have to write it once, and I'm still working relatively quickly. All right, top one I got 71.8 grams of water. I need that. Bottom part I got 83.7 grams of iron. I need that. Compared to the given numbers, I actually have 167 grams, and I actually have 36 grams of water. Okay, need 71.8, I have 36. That's not gonna work. If I needed $71.80 and I only had 36, I could not buy my item. So H2O is my limiting. By default, iron should be my excess. Let's check down here. If you did this way, you would figure out the excess first. I need 83.7 grams. I have 167. I need $83.70. I have $167. I'm gonna have money left over. So iron is my excess, and by default, water is my limiting. Doesn't matter which way you do it, still get the same answer. Okay, so for the last time, you only have to pick one way to do this. You can do it this way, or you can do it this way. I don't care. Pick whichever one you want, switch it up, whatever. Just make sure your work is right and make sure you're showing all the work. So you also have let me look at my plans here. You have a practice worksheet exactly on this stuff. So try that. I'll put the answer keys up for you tomorrow to check your work. And actually check your work carefully. Make sure you're not forgetting units, labels, things that I would take points off of. And then tomorrow you will have a actual graded worksheet that will be due on Wednesday. It's not terribly long. And that will be graded for not only completion, but correctness. So take advantage of these practice problems and the practice worksheet with answer keys. Chat me with any questions. Like I said, this is basically step 1 of chapter 9.2. In a couple of days, we'll add step 2 on, and then in a couple of days, we'll add step 3 on. Baby steps, people. Welcome to Chem 2.